Hello folks, so today we'll be starting our first lecture in GATE Aerospace Aerodynamics classes by AAE, the Association of Aeronautical Engineers. So first we'll look into the syllabus of aerodynamics. So this was the syllabus released for GATE 2025. So you can see there's four major topics: basic fluid mechanics, potential flow theory, airfoils and wings, and then compressible flows. ஸோ இதில் பேசிக் ஃப்ளூயிட் மெக்கானிக்ஸ் பார்த்தீங்கன்னா இதில் உங்களோட கவர்னிங் ஈக்குவேஷன்ஸ் வரும், பவுண்டரி லேயர் அண்ட் தென் சிமிலாரிட்டி, டைனமிக் சிமிலாரிட்டி, இந்த மாதிரி டாபிக்ஸ் வந்து பேசிக் கான்செப்ட்ஸ்லாம் பேசிக்ஸ் எஃப்எம்ல வரும். பொட்டென்ஷியல் ஃப்ளோ தியரியில் யுவர் பொட்டென்ஷியல் ஃப்ளோஸ், யூனிஃபார்ம் ஃப்ளோ, வார்டெக்ஸ் ஃப்ளோ, lifting flow over a cylinder, non-lifting flow over a cylinder, all these concepts will come under potential flow theory. And the airfoils and wings, very important topic, because you can see there's a lot of topic there: airfoil nomenclature, aerodynamic coefficients, pressure coefficients, and then wings and airfoils is a very important topic. And then you have compressible flow, which is basically the gas dynamics parts. Gas dynamics, mostly it involves compressible flows. We'll look into that at last. So we will start with airfoils and wings first. Okay, wow. So it gives a rough idea of how lift is produced, what a wing is, what an airfoil is, what are the nomenclatures. All these things we'll start first, and then we'll move to potential flow theory, and then basic fluid mechanics, and then we'll finally come to gas dynamics or your compressible flow. So first, in airfoils and wings, let us start with airfoil nomenclature. So today we will cover airfoil nomenclature, which includes your basic terminologies in an airfoil and also the NACA series. So here you can see this is an airfoil. So yeah, so this is your airfoil, and this is the leading edge. Leading edge is the most front part of an airfoil, which experiences the airflow first. And then here you have your trailing edge. Trailing edge is the most aft part of the airfoil. That's where your air leaves the airfoil. Airflow leaves the airfoil. And then this is your upper surface, and this is your lower surface. So here you can see for a conventional airfoil, the upper surface is usually curvier than the lower surface. So now let us define chord line and the camber line. So chord line, it's a simple definition. It's a straight line that joins the leading edge and then the trailing edge. So here you can see that orange colored line. It's the straight line that joins the leading edge and then the trailing edge. That's your chord line. Then what is the camber line? So this green colored dashed line, that's your mean camber line. So what is the mean camber line? Let us see. Let us take any sections on the airfoil. So let us take this section. You can see this violet line, right? Violet arrow. Let us say you cut a section there. If in this line you take the midpoint, where will it be? It will be somewhere around here, right? Then let us say we are cutting some section here. Here we are drawing a line, and if you take the midpoint of this, it will be here. So for all sections like this, if you draw many sections like this, and you plot the midpoints of all those sections, and you connect the locus of all the midpoints of the sections, then you will get your mean camber line. So your mean camber line, what it does is basically divides your airfoil into two equal halves. Okay, not symmetric halves, but two equal halves. It's basically the locus of the midpoints. So நீ எல்லா இடத்துலயும் பெர்பெண்டிகுலரா லைன்ஸ் வரைஞ்சிட்டு அந்த ஒவ்வொரு லைனுக்கும் மிட் பாயிண்ட் எல்லாம் கண்டுபிடிச்சு அந்த மிட் பாயிண்ட்லாம் ஜாயின் பண்ணீங்கன்னா வர லைன் தான் இஸ் யோர் கேம்பர் லைன். this is your chord line and this is your mean camber line, right? இந்த ரெண்டுக்கும் நடுவுல டிஸ்டன்ஸ் தெரியுதா? ஆரஞ்சு லைனுக்கும் கிரீன் லைனுக்கும், that's your camber. ஓகேவா? ஸோ இந்த இடத்துல பார்த்தீங்கன்னா உங்களுக்கு கேம்பர் கொஞ்சம் கம்மியாக இருக்குது, 2 லைனுக்குள்ள டிஸ்டன்ஸ் கம்மியாக இருக்குது. பட் கொஞ்சம் கொஞ்சமாக போனீங்கன்னா இங்கே இருக்கிறதுலே மேக்ஸிமம் டிஸ்டன்ஸ் இருக்குது க்ரீன் லைனுக்கும் ஆரஞ்சு லைனுக்கும் பேசிக்கலி. ஸோ கேம்பர் இஸ் த டிஸ்டன்ஸ் பிட்வீன் யுவர் கேம்பர் லைன் அண்ட் தென் யுவர் கார்ட் லைன். இது ரெண்டுக்கும் நடுவில் உள்ள டிஸ்டன்ஸ் தான் வி கால் இட் இஸ் கேம்பர். அண்ட் அது எங்கே மேக்ஸிமமாக இருக்கோ தட்ஸ் யுவர் மேக்ஸிமம் கேம்பர். And then this is the location of the maximum camber from the leading edge. So here is where you have your maximum camber from the leading edge. You can see, it's here. இவ்வளவு தூரத்துல உங்களோட maximum camber located. So location of maximum camber. And then thickness is the distance between the upper surface and the lower surface. Simple. So this is your upper surface, this is your lower surface. Here it's the maximum thickness. Here you see, let us say somewhere here, இங்க பாத்தீங்கன்னா இங்க உங்களோட upper surface இருக்கு, இங்க lower surface, இங்க thickness கம்மியா தான் இருக்கு. பட் அப்படியே போய் இங்க பாத்தீங்கன்னா you have your maximum thickness here. It's very large, the distance between the upper surface and the lower surface. So this is the basic nomenclature that you need to know in an airfoil. So next we'll move on to the NACA series. So NACA series, இது ரொம்ப ஒரு இம்பார்ட்டன்டான திங். ஏன்னா லைக் how will you identify an airfoil? Like how will you even define it? Think of it. Like அது நல்லா வளைஞ்சிருக்குண்டா, இல்லைன்னா கொஞ்சம் கம்மியா வளைஞ்சிருக்குண்டா, கொஞ்சம் நீட்டமா இருக்குண்டா, கொஞ்சம் தடிசா இருக்குண்டா. You can't define it like that. So you need some type of measurement and you need some type of reference. அங்கதான் this NACA came into play, National Advisory Committee for Aeronautics. ஸோ அவங்க வந்து பல காலமாக ரிசர்ச் பண்ணிட்டு இருந்தாங்க ஏர்ஃபாயில்ஸ்க்கு, ப்ரிலிமினரி ரிசர்ச்லாம் they did it. So they started naming the airfoil and the reference that they took is the chord length. So every parameter will be named will be measured in percentage of chord. So basically chord the reference மாதிரி ஒரு 20% of chord தான் thickness, ஒரு 20% of chord தான் 2% of chord தான் camber. இந்த மாதிரி எல்லாத்தையுமே chordலயே சொல்லுவாங்க. So they set chord as the basic reference or standard. So let us look at NACA 4-digit series. We will look at NACA 4-digit series and then 5-digit series. நிறைய series இருக்கு. We have 6, 7, 8 and then even 16. But as far as gate is concerned, they mostly ask 4-digit series and rarely 5-digit series. So we will only cover these two. So let us say that MPXX are your 4 digits. So it can be anything like 2412 or 0012 or 0015. And the MPXX என்ன digits வேணாலும் இருக்கலாம். So first M. Mங்கிறது is your maximum camber as a percentage of chord. So இப்போ அங்க ஒரு 3 அப்படின்னு இருக்கு, 3pxx அப்படின்னு இருக்குன்னா then 3% of chord will be your maximum camber. அடுத்து P அப்படிங்கிறது location of maximum camber. Just அப்படியே P இல்ல, you have to multiply 10. So P multiplied by 10, that percentage of chord is the location of your maximum camber. So let us say if P is 4, then 40% of chord is the location of maximum camber. Okay, and then XX, both digits combined in percentage of the chord gives you the maximum thickness. So if it is for example 1 2, then 12% of the chord is your maximum thickness. So we'll look at an example here. So you can see, let us take NACA 2412 as an example. So the first digit is 2. So 2% of chord is your maximum camber. The second digit is 4. 4 multiplied by 10 is 40. So 40% of chord is the location of maximum camber. And then the last two digit, it's 12. So 12% of chord is your maximum camber. So let us say that for a particular airfoil, for this 2412 airfoil, the chord length is 100 centimeter. Then the maximum camber will be 2 centimeter because it's 2% of the chord. The location of maximum camber is 40% of chord, so it's 40 centimeter. And then the maximum thickness will be 12 centimeters. Okay, now let us look at NACA 5-digit series. So let LPQXX be the 5 digits. Here, there's a bit of a difference. So L is your design lift coefficient. It's like the optimum CL at which that airfoil is supposed to, fly at. So that digit L multiplied by 2 by 30 gives your design lift coefficient CL. And then we have P. This P multiplied by 5 in gives you the location of maximum camber in percentage of chord. So here, it's given as 5 percentage. I mean, it's not like that. You have to multiply it by 5, and that number in percentage of chord gives you the location of maximum camber. And then you have this digit Q. This is an interesting digit because it tells what type of airfoil it is. 0 means if Q is 0, then it's a normal airfoil. If there's 1, then it's a reflex type airfoil. So here you can see this is a normal airfoil because this is a regular camber. The green line is just a normal camber. It has a normal curvature. Then what is a reflex airfoil? Reflex airfoil, has a kind of small reflex at the end, a small curvature in the opposite direction. So its curvature is like this, right? But reflex airfoils have little curvature like this at the end. So instead of going like this, the camber at the end near the trailing which go like this. So the camber will go like this at the end. How the pointer goes, it goes like this. So now there will be small reflex, there will be small deflection of the camber upwards. So that's the reflex airfoil. So the digit Q basically tells the type of airfoil, whether it is simple or normal or reflex. And XX, just like your 4-digit series, it tells you the maximum thickness in percentage of chord. So let us look at an example. NACA 23012. The first digit is 2. 2 multiplied by 3 by 20 gives 0.3. That's your design lift coefficient, CL optimum, something like that. And then you have 3. 3 divided by, 3 multiplied by 5 is 15. So 3 multiplied by, oh sorry, I don't know whether I would have said divided by, I don't know here, but it's P multiplied by 5. Okay, P multiplied by 5 will give you a number. That number in percentage of chord will give you the location of maximum camber. So here it's 3. 3 multiplied by 5 is 15. So 15 percentage of chord is the location of maximum camber. And then 0. So 0 is tells that it's a normal camber, not a reflex camber. The last two digits are 12. So 12 percentage of chord is the maximum camber. So again, if the chord length, let us say it's 100 centimeter, then the lift coefficient it does not change because the reference is not chord for the design lift coefficient. The location of maximum camber is 15 centimeter because it's 15 percentage of the chord. The type of camber is normal, not reflex, and then the maximum thickness is 12 centimeter. So this is all about NACA 4-digit and 5-digit series. All questions only come under these two series. So you need not இது ஈஸியான டாபிக் இதெல்லாம் கேட்க மாட்டாங்க சிம்பிள் அப்படின்னு நினைச்சிட வேணாம். இது வந்து நம்ம முன்னாடி படிச்சிருப்போம், பட் இதை மறந்துடுறனால நம்ம அங்க போய் இதை கூட தெரியலையே அப்படின்ற நிலைமைக்கெல்லாம் போய் நிற்போம். ஸோ ப்ளீஸ் ரிவைஸ் இட். கண்டிப்பா ஒரு மார்க் தாராளமாக எடுக்கலாம். சம்டைம்ஸ் ஈவன் ஆஸ்க் இட் ஃபார் 2 marks. ஸோ யூ கேன் ஈஸிலி கெட் 1 mark. 1 markன்றது இஸ் only those few 1 marks add up to the qualifying marks. So this is actually an important topic. So if you have any doubts, please do comment or you can mail to us always. Thank you.